Hello everyone, my name is Oğuz Khan and I'm Scientific Product Specialist at Simulations Plus. Today, I will walk you through a short demonstration of how GastroPlus Orchestrator allows us to interact with the GastroPlus simulation engine programmatically through REST APIs. We will see how you can set up your environment in Python and R, open and run projects using the API, and retrieve outputs and visualize results directly in your scripting environment through example scripts. Before diving into demonstrations, let me quickly point out where everything lives in your system. After installing GastroPlus 10.2, the two applications will occur in your desktop: GastroPlus 10.2 and GastroPlus 10.2 Web. GastroPlus 10.2 Web is a way to start the GastroPlus service with a port number manually, so that user has freedom to access and connect to this service to do API calls from their preferred environments. In this demo, we will launch GastroPlus service through R and Python packages, so we will not use this option. So let's move into the where Orchestrator components are stored. So I will navigate to File Explorer, this PC, C drive, Program Data, Simulations Plus, GastroPlus Orchestrator, and 10.2. You will find the Python package, an R package, and set of example scripts in this folder. Example scripts are really helpful starting points to replicate and modify your own workflows. Now, I will proceed to RStudio. Here we have already installed both GastroPlus API and GastroPlus R Modulus packages previously. I'll navigate to Packages tab and search by Gastro. Here you can see the two packages installed previously. I will navigate to GastroPlus API's documentation. Here we have provided a detailed documentation for all of the functions we support for the 10.2 release. I will click on a functions call here, and we have also provided detailed information how to make that functional call in GastroPlus API with an example here. Let's also quickly take a look at the GastroPlus R Modulus package. This package is a modular analysis tool for GastroPlus. We provided many useful functions to create quick plots and data handling. Please note that we utilize GastroPlus R Modulus package in the example scripts and recommend it to use in your own scripts as well. Now, let's open a new R script and take a look at how we can interact with GastroPlus from R. I will start by loading the GastroPlus API library. This package gives us access to the GastroPlus engine directly within R. I will type library and I will assign the GastroPlus API name inside of it, and I will execute the function. Next, I will establish a connection to the local GPX service, which is the REST API service running in the background. So I will type GPX web service, variable name, and then I will assign the output of the start service function here. Here, I will only assign the verbose argument as a true in order to get the service initiation details, and I will execute this function. See that the service initiation details are provided in the console with the port number, but you do not need to do anything with the port number. The package itself is going to handle everything. Once connected, we can open a GastroPlus project programmatically. Here, I will open a sample project file called demoproject.gp project. So I will use the open project function, and I will assign the project path arguments. Inside of this argument, I need to assign the path for the project. So this project is stored in the documents demo project here. What I'm going to do is I will shift right click on this GP project and I will copy as path. And I will paste the clipboard here. What I need to do here is I need to change the single backslashes to the double backslashes. And then I will execute the function. Now, the project is successfully opened in the service. What I can do with this project is, let me show you a simple function. So get simulations. So when I run this function, it will bring me to the simulation assets in the inventory. So you can see that there is only one simulation in my end right now. Once you are done with GastroPlus, you can terminate the service with GPX web service $kill. Now the service is terminated in the backend. Notice how straightforward this is. No need to use the graphical user interface if you want to automate workflows. So, in just few lines of code, we have connected to R to GastroPlus and loaded a project ready for simulation and further analysis. Let's take a look at one of the example scripts. I will navigate to example scripts folder and open up batch simulations run our markdown file. This script will execute the specified simulation and plot the CP time. These examples are structured as small, self-contained chunks you can run top to bottom. I'll start by loading the packages. We use GastroPlus to talk to GastroPlus service and Tidyverse for quick data wrangling and plotting. Next, we set the working directory to wherever this RMD lives, so relative paths work out of the box. Here, we start and connect to the GastroPlus REST service. This block is where you customize the demo for your own studies. We point to project file, specify the simulation name and run name, and also assign the observed data identifiers. Now, we open the project, create a batch simulation run, add our simulations to that run, and execute it, fully programmatically. After the run finishes, this block pulls back the results, such as the simulation keys and summary output from the simulation, which contains the pharmacokinetic parameters. Then we fetch all the concentration series from the simulation results, grab the CP time data, and then also get the observed data details from the inventory. In this plot results chunk, we build a quick concentration time plot with ggplot2. Overlaying the simulation profile as a line and observed data points as a markers. Here you can see the final graph created by the ggplot2. This is the concentration in plasma versus time graph for metaparallel tetrate 200 mg PO tablet simulation in the project. To clean up, we stop the local service so it doesn't keep running after the session. That's the pattern all these examples follow. Configure packages, start the service, set your inputs, run, pull results, visualize, and shut down. You can copy this R markdown file, change the project and simulation names, and you have got a repeatable, scriptable workflow. Now, let's move into an automation workflow. Imagine you have a set of drug candidates and you would like to quickly predict the pharmacokinetic parameters in GastroPlus using ADMET Predictor. With Orchestrator, you can automate this process so that multiple compounds are handled in one streamlined run. Here I have opened the example script, ADMET Predictor import 21 structures to a new project. This example shows how GastroPlus Orchestrator can automatically import a batch of compounds into GastroPlus through ADMET Predictor calculations and execute simulations, all in a single step. And while this particular example uses 21 compounds, the same workflow can easily be scaled to dozens or even hundreds of candidates, making it ideal for high throughput screening and rapid decision making in early stage projects. We start the same way as before, loading the GastroPlus API and helper libraries. This ensures we can talk to GastroPlus service and manage data frames in R. Then we will set the working directory. Next, we connect to the GastroPlus service and check if the service is alive. Then we will specify a set of input information, in this case project path and structure file to be imported. Then we will open the project and get the list of current compound assets before the ADMET Predictor import. See that our project does not contain any compounds as current compounds variable is null in the global environments. Here, the script loads 21 molecules to the ADMET Predictor module. Then gets the default configuration of the ADMET Predictor. You have ability to change the configuration based on your project purposes. Here, we change the dosing regimen and physiology schedule in the configuration object. Then we set the new configuration, and then we import the structures. Once imported, we can execute the respective simulation. This chunk executes the automatically created run, including all batch simulations from ADMET Predictor. Then it retrieves key outputs such as plasma concentration time data, which can be saved or plotted for downstream analysis. The data is stored in series data AP import variable. I will open this variable, See that all CP time data are stored in an organized way here. I'll navigate back to script and proceed to next chunk. This chunk plus the data provided in the previous chunk. You have freedom to apply any plotting to the data. Here, we plotted the CP time curve for each compound imported through AdMet Predictor. Here is another plotting example that you can compare your compounds based on pharmacokinetic parameters. As you can see, this workflow highlights the high throughput capabilities of GastroPlus Orchestrator. Entire sets of compounds can be imported, analyzed with AdMet Predictor, and prepared for simulations, all programmatically within minutes. Since we are done with the GastroPlus service, I will terminate the service with GPX service kill function. With this example, we completed the R side of the GastroPlus Orchestrator. Now we will proceed to the Python part. We have also provided a Python package for the orchestrator, designed with a very similar structure to the R package. This highlights the flexibility of GastroPlus Orchestrator, allowing you to work seamlessly in either R or Python depending on your team's preference. We will start with the documentation. Navigate to the Orchestrator folder, open the Python folder, and go to documentation. Here you can see a Markdown file called README. With an appropriate Markdown Viewer extension in Microsoft Edge or Google Chrome, you can view and learn details about the Python package. Here I opened up in the Microsoft Edge and we provided detailed information as we did in the R package. Now, let's move into coding part in Python. I will open up the VS Code and the new Jupyter Notebook. First, I will load the GastroPlus API library, which we have installed for the Python previously. And then, I will establish connection to the GPX service and configure the GastroPlus client. Once connected, I will open the same demo project with the following code. Notice that how it is similar to the R package. Once you are done with the service, you may terminate the service with gastroplus service.terminate. Now, let's take a look at batch simulation run example script in Python. I will navigate to GastroPlus Orchestrator folder. I will go to Python, example scripts, and here I will open up the batch simulation run.ipynb. We start by importing the GastroPlus API package and setting up a connection to the local REST service. This works just like in R. By default, it automatically launches the service, but of course a port number can be assigned by launching service with GastroPlus 10.2 web application as well. Here I will assign the setup variables related to my project. Then I will open the project and execute the specified simulations through runs. This is nearly identical to what we just saw in R, only the syntax differs. The important part is that the automation logic is the same. Next, I receive the iteration keys and summary outputs. Then I access the all concentration series for this simulation. Then I retrieve the CP time data and observed data. As a final step, I visualize the simulated CP time data. Here you can see the plotted CP time curve for the metoprolol tartrate 200 mg PO tablet simulation. So in just a few short steps, we have replicated the same workflow in Python, opening a project, running a simulation, and retrieving results. The key takeaway is that both R and Python interfaces provide the same power and flexibility, so you can integrate GastroPlus into whichever environment fits for your workflow best. That concludes the demonstration. Thank you for watching, and please don't hesitate to reach out to us if you have any questions.